Today I'm going to show you how to use the TK Madagascar main user interface. And the TK Madagascar interface is composed of mostly the sandbox, which is this first window that opens when you run SF GUI on the command line. So to get started with TK Madagascar, you just need to open the program browser from the view menu, and it pops up the program browser, which is almost identical to the standalone program browser, except we have 3 additional buttons here: add as flow, add as plot, and add as result. So I'm just going to show you here real quick how we can add various programs to our sandbox. And so again, we just select the program that we want to add, we click on add as flow, add as plot, or add as result. The mouse cursor turns to a crosshair to indicate that you're placing a flow where you want on the screen, and then you just left click to place it. Once the flow has been added, you can just click and drag to move it around. And if you right click on a flow, you're able to edit the parameters, link a flow to another flow, unlink, or delete it. So in this case, I'm just going to delete this extra spike. And yes, I'm sure I want to delete that. So today I'm going to show you how to make a Ricker wavelet in TK Madagascar. And as we go, I will just demonstrate some of this. So we want SF Ricker 1, then we want SF graph. And we want to add SF graph as a result because we want it to make a plot. So SF Ricker 1 and SF Spike are flows, as indicated by the black outlines here, and SF Graph is a result, as indicated by the blue outline. Just for reference, plots have purple outlines. So I'm going to go ahead and configure these flows and graphs, because all flows and graphs are in a default unconfigured state when you first add them to the TK Madagascar sandbox. And so to configure, you just right click on a flow and select edit parameters, which brings up the parameter selection window. And the parameter selection window allows you to just fill in the parameters as per the wiki documentation online. And so we're going to just go ahead and do that real quick. We're going to make a program named Spike, or sorry, a file named Spike. We're going to use 2 millisecond time sampling on the first axis. We're going to introduce a spike at the 100th sample, and we are going to use 500 samples on that axis. We can also click preview down here to see what our configured flow would look like inside of an S construct when everything is properly formatted, so we can see that everything looks okay here. And of course, if we're confused or we don't remember what a certain parameter means, we can always view the program self-documentation by simply clicking on View Documentation. So once I've configured a program, I can just click Accept, and that program goes ahead, is marked as configured, which is indicated here by the green background and the name of the output file here in this little area, as indicated by the bold text. So now I'm going to go ahead and configure the rest of these flows really quickly. And so we're going to make a Ricker file that uses Spike as an input, and we want it to be a 20 Hz Ricker wavelet. And then we're going to go ahead and make sure to graph our Ricker. Now plots and results are slightly different from flows, in that you only need to fill in the output field and not necessarily the input field. This is discussed more in depth in the online tutorial for SCONs with Madagascar. But we use the same rules as SCONs would. So now that our flows are correctly configured, we can do a number of things. We could run various SCONs commands, which I'll show you in another tutorial, or we could save the state of our sandbox, which allows us to then resume it at a later time if we want to continue working with this set of flows, or we can export it to an S construct if we're ready to go ahead and just run this from the command line. So that's been a short demonstration of how you can use some basic functionality in TK Madagascar.